Okay, so this problem is a simple proof. What they ask you is to prove that if p and q are two consecutive odd integers, then this thing right here, p cubed minus q cubed minus 2, that this expression is divisible by 24. Okay? There's a couple of things to take away from here. So the first step is always extract information from what they're telling you. Okay? So we know that whatever the result is has something to do with 24. We don't know yet what, but these guys created the problem and they know the answer. And if they know the answer, they know that there's going to be something obvious with 24 at the end of it. Okay, we just need to prove it. Okay, so and they're telling you that there's a p and there's a q that need to be cubed. Okay, and they need to be odd integers. Whenever we're talking about consecutive or one after the other, typically there's going to be the k involved, okay? So for instance, if they tell you that for every k, the resulting number needs to be an odd number, the way you ensure that is by doing 2k, which is always going to be even, and then plus 1. Okay, this number for any k is always going to be odd because whatever it is, whether it's odd or even for k, multiplying by 2 is going to create an even number, and then you add 1, and that's going to give you an odd number. Now, if they say consecutive, what's the next odd number after 2k plus 1? It's not 2k plus 2 because that would be an even number. So the next odd number after that is 2k plus 3. So here you have your two odd numbers that are consecutive, okay? Now, they're giving you this thing right here, so you're going to have to pick a consecutive, one of these consecutive numbers for p and one for q, but they're subtracting. So, of course, you're going to use the larger number as your p, which would be this, and the smaller number as your q. Here, p is larger than q. That's why we're picking this as p and this as q. And we're going to plug these into that formula or that thing that they gave us at the beginning, right? So if we plug these in, the formula or the equation that you're going to get out of this is basically p being 2k plus 3 cubed minus 2k plus 1 cubed, because that's q, right? I'm just filling in the blanks for this. And then minus 2. And the first thing we need to do is solve this thing out. These are binomials, so we're going to use the binomial tricks we learned before to kind of work this out. Now, we can do it all together, or we can do it separately. Just to simplify our process, we're going to do it separately. And because the n here is 3, we're going to use our good old friend, the Pascal triangle, to figure these out, okay? So Pascal triangle says 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and you can keep on going, right? But that's all we need because we have n equals 0, n equals 1, n equals 2, n equals 3. So these are the coefficients for n equals 3, which is exactly what we have, right? So now we're going to work these out on a separate page. Again, the coefficients from the Pascal triangle are 1, 3, 3, and 1, okay? So the first one we're going to use here is we're going to solve p, which, as you might remember, is 2k plus 3 cubed, okay? So let's work this out. This is a and this is b, okay? So the way that you do this, remember, is 1, 3, 3, 1, and then we do AB, AB, AB. It's always the same, right? Plus, 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 and then the exponents are n going down, 3, 2, 1, 0, and then n going down from right to left, 3, 2, 1, 0. And now we just fill in the blanks with a and b, okay? So this would be 1 times 2k cubed, right? Times b to the power of 0, which is always 1, okay? Then we add 3 times a squared, so 2k squared, times b to the power of 1, which is 3, then plus 3, okay, times a to the power of 1, and then b squared would be 3 squared in this case because b is 3, plus a to the power of 0, which is 1, times 3 cubed. Okay, so we filled in a and b into this, which comes from the Pascal triangle and the standard binomial approach. So we just now work this out. Okay, so we have 2 cubed. Again, remember, if you have multiplication in a parentheses all to an exponent, you have to apply the exponent to each individual item within it. So 2 to the power of 3 is 8, k to the power of 3, right? This is actually 3 times 3 is 9, 9 times 4 is 36, times k squared, okay? Then plus 3 squared is 9, 9 times 3 is 27, 27 times 2 is 54k, and then plus 3 cubed, which is 27. This is the result of expanding this binomial, which is p. We now have to expand q. q is 2k plus 1 cubed. Again, we apply the same formula as up here, right? And in this case, we fill in the blanks. So here it is 1 times 2k cubed times 1 plus 3 times 2k squared times 1 again, because b is 1, a is 2k, and b to the power of anything being 1 is always 1. So this one doesn't change, unlike the previous one, okay? So we have plus 3 times 2k plus 1, okay? So again, this is 8k cubed plus 12k squared plus 6k plus 1, okay? And this is our q, okay? Now, the original formula they gave us was p minus q minus 2. So p minus q, right? Let's see, do we have like items that we can subtract easily? Yes, we do. We have 8k cubed and ak cubed. So since subtracting, this minus that goes away. Then 36k squared minus 12k squared gives us 24k squared. Here we see that number that they gave us at the beginning. So something's kind of starting to work out here, right? So here we did, so 8 cubed minus 8 cubed, they go away, right? So 36 minus 12 gives us 24k squared. So here we're starting to see that this number that they gave us at the beginning, right? The next one is the k's. 54k minus 6k is 48k. And then finally we have 27 minus 1 is 26, right? So plus 26, but then we've done this. We still have to do this, which is minus 2. So now what we get from this is 24k squared plus 48k plus 26 minus 2 is 24, okay? You see this is repeating, 24, 24. There's a 24 somewhere in there as well. So if there's a number that repeats in every element, we can do this thing called factorizing, right? So basically we could take out 24 and leave k squared plus 2k plus 1, okay? Now, what's interesting here is that 24 is left out by itself. And remember, the original question was divisible by 24. What does that mean? It means that whatever the result is a multiple of 24, right? That's what this means. If it's divisible by 24, it's a multiple of 24. And so I ask you, is this, whatever this thing is it a multiple of 24? Yes, because it's multiplying by 24. This is your proof that that statement that they gave me in the beginning is correct.